Can you guys hear me at the back? Yes? Okay, fantastic. Okay, so the topic of our presentation today is graphics debugging and debug graphics. They both sound really similar, but actually quite different. I'm going to go through graphics debugging, where I will show you how to find issues with your graphics and hopefully fix them before they're released to your users. And Gustav is going to go through debug graphics, where he's going to teach you how to add graphics to your snappers to solve certain problems. So, first of all, let's just look at the basics of graphics debugging. We will look at ways to detect non-obvious problems with your graphics. When you have graphics, it's almost impossible to know if the polygon count is high or if it's going to cause performance slowdowns just by looking at it in your 3D view. So when you're testing it, when your QAs are playing around with it, it's almost impossible to know how slow it can be if you were to add 1,000 snappers and so on. So we're going to look at ways to detect this before you even release it to your customers. And when you fix all your graphics issues, you can actually improve performance greatly. And I will share some examples with you later, some code even, and hopefully that will give you a good idea of what this whole thing is about. So all the tools that I'm about to present to you are available in Custom Developer, so you can actually extend them, modify them, and use them in your own extensions, like what Christopher has done. And it can be used by QAs even, so hopefully you will encourage your QAs to test graphics when you're done with the snapper. So we're going to look at 3 different areas today: level of detail, caching, and also visibility. The focus is going to be on level of detail because we've done quite a bit of work on it over the last couple of months, especially in KL. We have fixed the level of detail for a lot of our snappers and it has improved performance tremendously. We'll also look at caching and visibility because we have these tools in Custom Developer, but no one seems to be using it, no one seems to know about it. So I'll just like to introduce you guys to these new tools that are really, really good actually. So, level of detail, a lot of you guys may already know this, but then it's just a way of controlling the complexity of your model. The closer your camera is to your model, the more complex it should be. If your camera is really, really far away, there's no need for your model to be super complex. There's no need for you to have curves, for you to have a great amount of detail. So you can hide all of that, and actually all of that is handled by our LOD system. It's super efficient if you get your models done correctly. If your models are well optimized, the system will be super fast. But if your models are not optimized, it can cause a lot of performance issues. Your system can get really, really slow. And I've got an example for you. I've prepared 2 sets of snappers. On the left, we have the good snappers, the guys with really well-defined LODs. We have a low, medium, high, and super. And on the right, we have the bad snappers, where we just have super all the way. So even if the camera is really far away, the T-pods on the right are still going to have super as their level of detail, which means each and every model will have approximately 12,000 polygons. So let's go to the code. Oops. Oops. You see it? How was it?
You need to choose one of the presentation.
Okay. This one. Okay. So I have this little window here. What I'm going to do is I'm going to first add 100 of the good snappers and then 100 of the bad snappers, and I'm going to do a comparison. And then I'm going to move on to the next stage where I'm going to do a comparison with 3,000 snappers, and finally I'm going to do one with 6,000 snappers. And you will see how the snappers gradually slow down the system. So we'll start with 100 of the good snappers. These guys. They look really good. You can rotate, you can zoom in, zoom out, no problems here. Everything looks good. And you can see when the camera is close to the models, they turn blue, and the ones further away are green. And if it's really far away, they turn red. Okay, so that's what we want. I'm going to now add 100 of the super snappers, the bad snappers. It's still okay, no problems. You don't see any slowdowns. So this is fine. And QAs and also developers normally test their snappers with just 100 of them. They replicate 100 times, 200 times, and they don't really see the issue with it. But when your user is dealing with large drawings with thousands of snappers, then it will really, really slow down the system. So let's now try with 3,000 of the good snappers with LODs. Still looks super fine. everything's very fast, no problems here. And if I were to switch over to the bad snappers, now you will start seeing some slowdown. When I rotate, it takes some time for the system to respond. And this is still okay for a lot of our developers. The new developers, they probably won't see it, they won't really feel it, but most of our experienced developers would probably be really frustrated by now. And our users also, I guess if they were to deal with drawing like this on a daily basis, they would get really, really annoyed. But it's still not all that bad yet. Let's try with 6,000 snappers now. So we have 6,000 snappers with well-defined LODs. It's still super responsive, super fast. So it shows that the system is really capable. The LOD system really helps improve performance. It responds almost instantly. I don't feel any lag whatsoever. And now if I were to try it with 6,000 snappers with super LOD.
Here we go.
Yep, wait for it.
It's gonna blow up.
So now it takes so much time just to even rotate the drawing. I've already rotated it, by the way. So it is really very slow. And you may think this never happens, but it actually does, especially now that we have catalogs where customers have catalog creators upload models directly. We don't actually look at the models before they upload them. This actually happens. We had a customer where the code was good, everything was fine, but the performance was really, really bad. And when we looked at it, they were actually uploading really high quality models for every single snapper. And this was the end result. The users were really frustrated, and we had to go in and fix all of these models. So how will a QA know if the models are of really high quality, if they are going to slow down the performance just by looking at them? They wouldn't know, right? Even developers wouldn't have a way of knowing. So we created something really simple, but really effective, I believe, to help solve this problem. We have something known as the model performance dialog, and it shows you the polygon count and also the expected or the recommended polygon count for that exact model. So if your polygon count exceeds the budget by a lot, then you know for a fact that it's going to cause performance issues down the road. So this is a great way not just for developers to test their snappers, to test their models before releasing it. It's also super easy for QAs now to test their stuff. So I'll show you where this dialog is and how you can use it and how effective it is when it comes to testing.
Yes.
So frustrating. Got to exit, right? Okay, so we just have to go to the performance tab and select model performance, and you will see this dialog. And I'm just going to add 2 of those snappers, one good, one bad, and I'm going to do an update. And you will see that for the good snapper, with well-defined LODs, everything is green, everything looks good. So 327 refers to the actual polygon count, and 336 refers to the recommended or the budget. So if you don't exceed your budget, or if you exceed your budget a little bit, then it's fine. But if you exceed your budget by a great amount, like the one in the first row, then something is really wrong, and you've got to fix it. And there are several other tabs here that you guys can. Yep, yes, Rob.
The budget, is that something that is calculated based on the dimensions? Because it's a very odd number.
I actually do not know how the budget is calculated, but we already have the,
Maybe it's calculated based on the density of the mesh.
Like the super is coming as input in the model. So from the super's polygon count, because nothing will be reduced, but is coming as in the super. Based on that, our other budgets will be.
Okay, so we also have several other tabs here. The missing LOD and the detailed mask tabs. These tabs give you more information about what should be fixed. And finally, we have the Excel export tab. This is something that's super useful for QAs. If you want to do a performance hunt session, if you want to fix all your models, for instance, you can do an Excel export before, and then do all your improvements, and then do another Excel export at the end, and you can compare the results to see how much you've improved and how good it's become. And it's also really easy to add all the snappers from a certain extension or from all the available toolboxes here. So if I want to just add snappers from the current card, if I click on this and I just add from the current card, I'll get all the snappers from this selected toolbox, and I will see all of its performance here. and what should be fixed, what should be ignored, and so on. And I can also select individual cards if I want to. So you can play around with this, and it makes a huge difference. We did this to all of our KL extensions, so our KL core extensions, and I think the performance has been fantastic ever since. So try to do this, and yes, hopefully you'll see much faster snappers next time around. Okay, and here's what the Excel export looks like. It shows you an overview of how good your snappers are for the extension. So you can try this out, and you can keep track of it to see how much you've improved or how bad your extension has become. Okay, next we have caching. Developers sometimes forget to cache their models. It happens to all of us. And it's always nice if your QAs can actually find these problems before you release the extension, right? Before your users start using it. So we have a cache animation now. You just select a snapper, and it will show you whether or not it has a complete cache 3D implementation. So I've got to quit this. So I will select this scarecrow and then go to Emacs. It will show me that it has a complete cache 3D implementation. So this is really good. If you're testing individual snappers, this is something that you should do, or your QAs should do at least. And finally, this is something that I don't think anyone really uses. It's really good when you're debugging visibility settings. When you're debugging visibility. We have a visibility animation, but as far as I know, people use it to find out, to see their local bound. They don't use it for the actual purpose of it. So if I go to this guy over here, and I select the snapper, it shows me in which modes the snapper should be visible in, what layers the snapper has, and so on. So it's super useful for debugging. We often get questions from a lot of our developers regarding layers and categories. So this would be really, really useful if you have those sort of problems. Okay, that's it from me regarding graphics debugging. I will now let Gustav talk a little bit about debug graphics.
Debug graphics. So this is a topic that we are using within Configura a lot, and I don't know if everybody is using it, but it's really helpful. So let's move on to the presentation. So there are many ways to adding these graphics to CET. One of the ways is the red graph helper, and it is under CM Core Red 3D Debug Red Graph Helper, and you can add graphics to the scene here. So like direct lines or spheres or rectangles or coordinate systems, whatever. And it's easy to add and remove stuff from here. So I will show you an example of how it can work. So as you can see here, this is the red graph helper file, and so we have a red graph helper initialized up here as well. And here's my small test code. So let's try it. Right now, I will remove everything from CT Designer, and we'll see how it looks like. Okay. So let's try to add a line first. You see, I'm adding a line from 0, 0, 0 to 2 to 10, 10, 10, and it's red here. Okay, no, I didn't. Okay, apparently I'm not. Okay, this has worked before. Just restart. Compile and see if it works better. So like this is very useful if you want to add graphics to try something really fast, because you don't need snappers or anything. You can just add graphics, add lines, spheres, cubes, whatever. We have the interface down here for adding stuff. So like you can easily look at this and see what you can do, and it's really helpful. But sometimes you need more, and I will come to that later. And I'm just going to see if this works now, and it just did before, so it should work. Yes, here we have my line, and it's an example here, and I can add the other stuff as well. I can add a coordinate system here as well, and some sphere.
Yeah.
And it's really helpful sometimes to have this, you know, like freedom to add stuff, just only graphics, because it's much faster than adding a snapper that adds graphics. Yes?
I think I asked you through developer support a couple weeks ago about this, and it helped me a lot because I was trying to do some raycasting to determine objects around me, and using the redgh.add, I was able to see the actual raycast
And that's perfect.
what it was hitting, so it helped me a lot.
Yes, that's perfect. But sometimes yes, so we also have we also have this tool that Magnus and Jaron showed yesterday, that the summer workers created, that is actually using the red graph helper. So it's utilizing it, and you can find it in a dialog, and it has some extra functionalities like showing wireframe and show normals of models in CT. And you can find that tool up here under Debug, as you can see yesterday. Where's it? Okay, here it is. So you can add, but I need a snapper, of course, to do this. And I can add normals to it and see every normal, and also other stuff here. Coordinate system again. This is the same coordinate system as I added in the red graph helper, for example. And this is also very helpful for seeing more stuff, you know, like adding graphics to debug as well here. So, and this is really good, but sometimes you need to add more graphics for debugging. For example, if you have connectors and you want to see like where they are, or you have some other functionalities and you want to see something else, you know, graphics is a really helpful tool to debug different stuff that you're creating. So I created an example. I'll just clear everything here. And then I'll add because we are in Vegas, I have a black egg table. It's not that pretty, but it's green, and I like it. And you want to put chips on the table, right? And other stuff. So I have a chip here as well. And oh, it isn't really working here, as you can see. The connector here isn't really good because it's falling through here, under the table. So I need to see what's going on there. Let's show both 3D and 2D. Okay, so I've added a debug flag up here. It's called debug support. That's actually adding extra 2D to debug. So I'm adding the 2D of my support surface here to see how is it really looking like, because this is really wrong. And you know, like, it's really helpful in this case to add graphics to debug here. So I can see where I can put my chip here. So like if I'm putting it here, it's on the floor, but here it's on the table. So like, this is a really good use case, and we actually had this problem in a project that I'm working with. So it is a real problem that I've actually had, and we added these graphics to see what the support surface looked like, because we were taking the support surface from the graph, and it got really messed up. So but there is even better ways to add graphics, and we have this really good guy CJ that's adding a lot of cool stuff to 8.5, like vessels, animations, new animations, and other really cool stuff. And he's added a so I've actually done the same thing with a vessel as well. So a vessel is an information carrier, and in this case the vessel is carrying my debug 2D, and it's inside my animation. So like, when my animation is running, I am showing the debug 2D in this case. So I can jump down here to the animation start. So I'm starting the animation here in my insert chip animation code. So if I change animation here, it's all over this one though. So the debug 2D will be shown here when I'm trying to connect to my table. And this is really cool. I'm only adding the vessel to the animation. And when the animation finds a snapper candidate that it's, you know, like trying to connect to or like aligning to, I'm adding the 2D through the vessel to the animation. Or yeah, the vessel is showing its 2D through the animation. And this is just one case where vessels is really helpful, and they can give a lot of value. You can add vessels, you know, like you can have like one animation, and you can add vessels to change how that animation works. I mean, I can add anything here. I can add, you know, like whatever. So like, this is just one case. I don't need to have like 5 animations doing like the same thing anymore. I can just add vessels, 5 different vessels, and add them to the animation instead. So look at vessels. They're really good, I think. You should really try them. And I think it was really good for this case when adding graphics like this. So yeah, I think that was all for us. And I just want to say one thing. December 6th, we have a mini conference in Sweden, and please come there.
I'll be there.
It's free. You only need to have a flight ticket there, and yeah, that's all.
Okay.
And we will cover some topics from this conference and some new topics as well. That would be really good.